Folks, we're back. Kathy and Squirrel, if you remember, come to do a bit of maths. So we've got some starter questions here. Last lesson we learnt how to find a confidence interval. What is a confidence interval for? Squirrel, what do you think? Sit on Minnie. Well, you've forgotten. A confidence interval is for finding an estimate of mu, the population mean. If you remember, we don't give a point estimate because this is quite unlikely to be correct. So rather than giving a point estimate, we give an interval in which we think it's going to be in. Okay, next question. What is the formula for a confidence interval? Let's hope you remembered that one. If you didn't, or if you've written it down somewhere you want to check, here we go. It is x bar, which is the sample mean, plus minus z times standard deviation, whichever it's s, whether it's standard deviation, you put sigma if you want, over root n. Okay. Now question 3. What is the value of z for a 97% confidence interval? Well, Squirrel, what do you think? If you get your calculator, yes, your friend, probably your only friend now. So we want to go to statistics mode. Press, when you're in stats mode, press, if you've got exit, press distribution, normal and inverse on the F3 button. And then because you're doing confidence interval, tell it the tail is central. The area for this one, 0.97. Want a Z value here, so standard deviation is 1 and mean is 0. And then you should get on your machine these two numbers. Let's see if you've got them right. So this is question 3. Sorry, squirrels are here. Let's go into basket. Let's write it down. It is Z will equal plus or minus on your machine showing 2.17 and a few other numbers. Next question, number 4. What is another name for the standard deviation of x bar? If you remember, I showed you x bar followed a normal distribution because that's the distribution of means. The mean, whatever the mean is, which is mu, and standard deviation for this was sigma over, variance for this was sigma squared over n. That's the variance because we put mean and variance in the brackets as the parameters for x bar. But the standard deviation, if that's the variance, the standard deviation is sigma over root n. Now another word for this, a whole thing together, or it could be s over root n, wouldn't matter. But the whole name for that thing is called standard error, S.E for short. Number 4 again, oh that's not quite right. It says complete and try these suggested questions on paper. So I did give you a handout with these on, I wonder if you've still got it. Otherwise we can just, you'll have to just watch and pause the video. So here's the first question. Give some numbers, tells you standard deviation is 3.5, normally distributed. You've got to construct a 95% confidence interval for the mean volume of lemonade in a mini can. Give your answers to 1 decimal place. So please pause the video and have a go. Right, hopefully you've paused and you're playing again. Here's the answer. Hope you got it. Right, next question. Again, pause it, have a read and have a go. Squirrel. Hope they're pausing. Okay, you must have had a go by now. Hope you've paused me. Here is the answer. %, confidence interval was 1.5 to 1.6. To find the x bar here, you had to add the two limits up and divide them by 2. That gives you what x bar is in the middle. So then the 90% confidence interval was 90 z90 times sigma over root n, which gives that, and so on. Okay, right, last question. Bit harder this one, you'll probably struggle, but have a little go. Please press pause, or you might have your worksheet there, but do press pause before the answer appears. Thank you. Okay, probably unpause now, wonder what on earth I'm doing. So here is the answers. I'll talk through some of it. Okay, hope you've had a go at this. The first two bits, probably straightforward. Your Z value and making a comment. Part C, a little bit different. This one may have caught you out. You asked for the percentage of the test, so you're after the Z value and then doing something with that. You're told in the question that the confidence interval limits are these two, 32 and 38. Well, this is how you tackle it, maybe, or you've got another way that works fine. Right, I've done it by looking at just the upper limit. So if we're calculating the upper limit, it would be x bar plus some z percentage times standard deviation over root n. And that equals that upper limit. So you can take that off there and get that. You can times that by root 10 and divide by 5.8 and get this. And then you know that the z value then is that for the upper limit. So it's obviously going to be minus it for the lower limit. So those are the two z values. So percentage of the test is the bit on the diagram here, the area between those two sticks there. Now, you could get it the old-fashioned way with the old calculator by doing the probability of this, take the probability of that, gives you the area in the middle. However, you've got a lovely calculator, so you need to get to this screen here that says normal CD. So to get there, you need to go into stats mode, press exit, exit, exit to make sure you're in the right place, press distribution, F5, F1 normal, and now F2 for NCD. NCD, then you should see this sort of screen. Can you put in those lower and upper values? Make sure, because we're after a Z value, standard deviation is 1, mean is 0. Then press the EXE button and up should come this information here, which is telling you that the area between those two limits is 0.8635. Rounded mine 864. So basically the percentage of the test was 86.4%. Well, okay. Oh, we could have a quick sing a song of this again. If it works for me. Oh yes.
We want to find an estimate of mu. We want to find an estimate of mu. We could give a point but could be wrong, so an interval will be far more strong for the population mean, that's known as mu. for the population mean that's known as mu. This interval is x bar plus minus, plus minus. This interval is x bar plus minus, plus minus, plus minus. What I hear you say is z times st over root 10, which is also known as z times standard error, which is also known as z times standard error. The z is found by pressing inverse normal, inverse normal. The z is found by pressing inverse normal, inverse normal. And now we are a percentage sure the population mean is quite purely in the interval we've now found. Yes, in the interval we cleverly found. We want to find an estimate of mu.
Okay, back to confidence interval lesson 2. That got the cat excited. Right, so we're doing it here with unknown variance. Ooh. So today we find a confidence interval for the population mean using a sample from a normal distribution with unknown variance. We're going to find the confidence interval for the population mean using a sample from a distribution with unknown variance. Is that the same thing? Odd. And to be able to discuss whether the confidence interval calculated includes a hypothesized mean value. Ooh, that sounds harder than it is. And we're going to be working to work out confidence intervals on our calculator. Right, what a waffle. Right, C. Oh, using an estimated variance. So when the population variance, which is sigma squared, is not known, but n is greater than 30, an unbiased estimate of the variance s squared can be calculated using one of these two formulas here. Now, depending on who you had for normal AS maths, they may have shown you these or they may not. Here they are anyway. They're slightly different to the sigma calculations, and they are on your calculator when you put data in it. If you've noticed, there was a sigma and an s that were very close together. The s is just a little bit bigger than the sigma value, but here they are. If you need to calculate unbiased estimates of the variance or standard deviation, use these. Those give you variance. Obviously, if you square root them, you'll get standard deviation. This one is in your formula booklet. This one is not. So you have to remember that thing. If we have done that song, not sure if we did actually. What was the song anyway? Yes, we have to find maybe I did it in my group. Find the standard deviation of a set of data. Add the x squared up, divide by the total n, subtract the squared mean, and don't forget to root it. That's when you have the standard deviation. But for the sample standard deviation, you have to times it by n over n minus 1 before we square root it. Right, so when the variance or standard deviation are not known, replace sigma squared with s, or sigma with s. Should do that really, but you won't be penalised if you forgot. Thus, the 95% confidence interval formula looks like that. So very similar to the last one, but rather than sigma, we've put s. If you're ever so confused, just put st and then it can stand for either. But let's move on. Right, a question. Super. A random sample of 64 sweets is selected. Yum, yum. Their weights are summarised by the following. Ooh. Calculate unbiased estimates for the mean and variance. Right. Off we go. So x bar here. Whoops, let's get the pen going. Oh no, we haven't got the right colour. That's it, good. So we've got x bar equals, now we'd have to do the sum of the x's over n to find the mean, and if you do that, there's your n, there's your sum of the x bars, so that works out at, I've done that before, Oh, looks like I didn't. Oh, I did. Yeah, here it is. So you're dividing that by 64 and it gives you 0.932. Right, to find the standard deviation, because it says find the unbiased estimates of the variance. So the variance isn't known, so we estimate it at s squared. We use the formula we've just seen a minute ago, which was 1 over n minus 1 of the sum of that exact thing we are given here. So basically all we're doing is dividing 0.63 by n minus 1, which is 63. Ooh, I can do that in my head. Right, let's squash it on there. Equals 0.1. Oops, go away you. Right, and then you have to square root that to find, oh, silly me. Let's check that. Maybe I got it wrong. Menu, so that's 0.63 divided by 63 equals, oh yes, I did get that wrong. That's 0.01, isn't it? And that means our S value is, when you root that, you get 0.1. Okay, now we have to put it in that formula X bar, so you'd write that number plus minus, so we're after a Z99. Z99 will equal plus or minus something here. I've got now to find that. It's menu, statistics, distribution, normal, inverse. We want central as the tail, 0.99 as the area, sigma 1, mu 0. Press EXE and you get plus or minus 2.576. Right, so that'll be that number there, 2.576. Oops, lost me 7. Times standard deviation, which is 0.1 over root n, which is root 64. I could do that one in my head and get it right. Say, feel confident there. Right, if you do all that, you'll get your limits for your estimates of mu. So you write 99% CI for mu is, so if you do it with the minus first and then the plus afterwards, we would get 0.900 up to 0.964. If you want units on it, it is it grams? Weird, doesn't mention it, but it'd be grams. Okay, right, so that's that. If you want to check that on your calculator, you can go into stats mode, press interval Z1 sample, put all the info in, and this will come out. Remember, in the exam though, they're giving marks for writing that 2.576, so they'd want to see this line here. They need that line, and then you can use your calculator to do that afterwards if you like, but I want to see that line written, and then use your calculator to get this if you want. Right, next we have another one. Okay, a machine cuts wood to form stakes, which are supposed to be 200 centimeters long. What do you use stakes for then, I wonder? Killing vampires, you might think. Well, let's see. A random sample of 40 stakes is taken, and the stakes are accurately measured. Their lengths x in centimetres after subtracting 200 centimetres from each measurement are summarised by these two things. The values are very small because they've all had 200 taken off them. So it's what's called coded data, isn't it, when we reduce the number by something. So everything's had 200 taken off it, and then those measurements have been added up. There have been some negative, some positive. They added up to a positive number of 41.5. 56. And sum of x squared is given by that thing. It says calculate unbiased estimates for the mean and standard deviation. Okay, off we go then. A. Biased estimate. Right, so mean x bar will equal sum of the x over n, and our n is 40. So that works out at 1.039. But obviously, if you wanted to be giving an estimate in terms of the length of those sticks, you'd have to, so you subtracted to make this code, we'd have to add 200. So you wanted to give or x bar for reality is 201.039 centimeters. The standard deviation, so our s squared, that's the variance actually. So what we'd have to do here would be n over n minus 1 of sum of the x squareds over n minus the mean squared, which is x bar squared. You do all that, you'd have 40 over 39, 107.46 over 40 minus, because we're using the coded data here, I'll minus 1.039 squared. And if you do all that, you'll get a coded variance of, no, I didn't bother, of something. And then when you square root it, the S coded variance will be 1.2838. Now, if you wanted to unchange that, you've got to ask yourself, does subtracting 200 from every value affect standard deviation, affect spread of data? Well, it doesn't. So that's the coded and the correct standard deviation for it all. Right, construct a 95% confidence interval for the stakes. So B here. What have we got? So we can use the real one if you like here now. So we've got 201.039 plus minus, we're doing a Z95, so you might remember that's 1.96 times S, which we've just found to be 1.2838 over root n. So you've got to write that sentence there. They want that in the exam. Then you can use your calculator if you want and get your confidence interval. So the confidence interval there is, so a 95% CI for mu is 200.64 to, we can put comma or a slash, it doesn't matter, 201.44, and those are centimeters. And hope you kill your vampire with that. All right. Here is just telling you how you just check that on your calculator, what you put in there. Well, if you're checking on your calculator, interval Z1 sample, your sigma, you'd put your sigma in as those things we've just calculated. So that would be your although it's S, 1.2838. Your x bar was 1.039 and your n, well, that was 40, wasn't it? You want to compress all that and just check you get that same interval as I got a minute ago. Right, complete the match cards. Well, you won't be doing that, but you might want to have a go at 2 of the match cards. So here we have it. It says, oh, but you can't, it's saying but, as you can't do the matching. These two of them. Try these two questions. So you're going to have to press pause for a while and have a go at those. So it's no story, but you're given N, some of the things, and that funny formula. You need to calculate X bar, unbiased estimator S, and then do me an interval. And then the same again, but with the data given in this way. So you'll have to use the other formula for standard estimate of standard deviation. Do the same. So please pause. I'll enjoy my cup of tea. Okay, so you're on pause now. Here comes the answers. Hopefully these will look familiar. So on that first question, the S was that, the mean, sample mean was that was the Z you were using, that's the interval it came out with. Second one, that was the S, that was the X bar, that's the Z you should have been using, and that's the interval you would have got. Super. Right, interpreting confidence intervals for the mean. How do you interpret a 90% confidence interval? Well, this diagram's a bit bonkers, isn't it? What this diagram is a diagram of 100 confidence intervals. So here's a scale of what the confidence interval mu was between 6 and 9, it's saying. But this interval found it was between, first interval found it was maybe between, that says it's 7.3. Maybe 7 and 7.6. And then there was another interval, then another interval, and then another interval. So these are for 100 different samples. You had this massive population, and somebody came along and did a sample, and somebody else came along and did another sample, until we got 100 samples done. And then for each of those 100 samples, they took a confidence interval for mu. We later knew that the actual population mean was in fact 7.3. So looking along that line, how many of those confidence intervals did not include that true population mean? Well, you can see 1, 2, 3, 4, 5, 6, 7, 8. Ooh. Any more? Yep. 9. And there's got to be one more. No, where it is. Do do do. Oh, there he is. 10. Right, so we see here, 10 out of those 100 didn't in fact include the confidence population mean. Oh, so not 100% reliable, only 90%. So what can we say? We can say that 90% of the confidence intervals calculated for the mean will in fact contain the true population mean, which is 7.3 in this case. This in turn implies that 10 out of 100 confidence intervals calculated for a population mean will not include the true population mean. So in other words, they're not 100% reliable. So not perfect. However, the higher the percent you get here, the more reliable the confidence interval is to be, to have the true population mean in it. But obviously, there'll be a larger interval if we're more likely to know that the definite population mean's in it. Right, so back to those sticks of wood and the vampires. This question relates to that. So it says, by considering the 95% confidence interval calculated earlier, which I'll write down, what was the numbers? Ooh, can we remember? No. Right, there were 200.64 to 201.44. Right, so considering this, we've got to, what was this again? Forgotten. By considering the 95% confidence interval, does it appear likely that the stakes cut by the machine have the required mean length of 200? Well, does 200 lie in that confidence interval? No, no, it does not. Oh. So, we can be only 95% certain the confidence interval includes a true population mean. And this interval does not. Include 200 centimetres, the supposed mean. Therefore, it is unlikely that the lengths of stakes cut by the machine have the required length. So in fact, it looks like they're getting a bit more for the money. Not a lot more, but a bit more. The company might not be pleased that giving up too much wood away. Customer might be pleased they've got a longer stake to kill the vampire with. Who knows? Right, part C. State the probability that this confidence interval does not contain the mean length of wood as stakes. Sorry, I'll start again. State the probability that the confidence interval does not contain the mean length of wooden stakes cut by the machine. Well, if we're 95% sure the mean is in there, we're going to be, no big shakes here, 5% likely that they're not. So not every confidence interval will have that true population mean in it. And if we're using that, 95%, there's a 5% chance that it won't contain the population mean. Now, here's a question for you. Have a go. It's all about firemen. That brings me to the calendar. I might go and change it because it'll be April. If you can zoom in there, but it is firemen. Very apt for this question. Right, so you pause the question and have a go, and then we'll flash up the answers. Okay, you should have had a go by now. Here come some answers. Okay, let's see if you've got this right. So find the mean and standard deviation. There they are. And then construct a 99% confidence intervals. Use I've used 2.58 and got those two values. Part C said the fire and rescue service claimed that the station mean call out was less than 5 minutes. Well, they're liars, because this isn't less, 5's not in there. Now there's anything less than 5. That's not true. Whereas the parish grumpy councillor suggested it took more than ooh, can't see because I'm in the way. I'll read my sheet. More than 6.5 minutes. Well, he's a grumpy old man as well, because it doesn't take over 6.5 minutes, because they say in the top limits we're at the mean times 6.08 minutes. So both of these claims are rubbish because they're not inside the confidence interval for our mu. Okay. There's the Mop scheme for it if you want to peruse that. enough of that. Right, recap. A 95% confidence interval tells us that there is a probability of 0.95 that the confidence interval contains the population mean mu. I haven't got fleas, I've just got this terrible bad shoulder. If the sample is taken from the population, the normal population, then 95 confidence is given by that formula. If the population variance is not known, you replace sigma with s squared and you get that formula, which looks exactly the same as that formula. Without sigma, it's going to have got an s. And now it says you can try exercise 6b, which will be on your homework sheet. Super. There are a couple of other questions you can have a go at, and here they are. You can pause the screen again and have a go at these before you start that exercise. Number 3 is quite tricky again. It's a bit like the one we did at the start. If you remembered how we did that, you'll be able to do this one. It's got that E thing again. And number 1 seems very straightforward. Anyway, pause the screen, have a go. Okay, here's the answers. Number 1. That's number 2, isn't it? And question 3. Parts A and B. Yep, not too tricky. Part C. C over. Let's do it again. Here he is. Right, here's the answers. I did it in the same way as B there. I did upper take lower is 25. Then if you subtract that, the x bar disappears. So you've just got 2 lots of this formula basically. Equals 25, divide through by the 2, times through by the root 90, divide through by 103, get that value. Now if you remember how we calculated that, that was a bit of a fast. It means with that diagram your z value between plus and minus that z thing. The old calculators you had to use to do that. But you're after this area here. Now you've got lovely machine. Go to, let me describe again, stats mode with your friend. You could also get, no, anyway, just your friend, before I say anything silly. Go to stats mode, press distribution F5, F1 normal, and then we're doing, because we're trying this thing, you need to press NCD, normal cumulative distribution, that's what it stands for. And then you get up this screen, you'll have to enter the lower and the upper values after Z numbers, so keep the sigma as 1, which is variance of 1, and mean of 0, and press EXE, you'll get that, which tells you that that probability in between those two things there is 0.8697. So basically, percentage of this test was about 87%. Hope you managed that one after we'd done it right at the beginning, but it was a bit clearer now. Okay, I think we're about done today. You'll find out what to do on the homework sheet when it comes. Hope you've enjoyed it. Tried to get another cat to come up, but wasn't impressed with the maths, to be honest. Frightened. Hope that's not you. Hope you're more like Squirrel and enjoyed today's maths lesson. You're still here. Here, babes. Can't wait to get on with the exercise, as you can see. You want to say goodbye, Squirrel? Bye-bye. We shall see you after the holidays. Hope we're giving you enough homework to keep you out of trouble. Stay safe and see you after Easter.